Protein intake and exercise induced skeletal muscle hypertrophy. An update. Journal list nutrients v.12.7. 2020 July PMC 7400877. Abstract skeletal muscle mass is critical for sport performance and in many pathological conditions. The combination of protein intake and resistance exercise is the most efficient strategy to promote skeletal muscle hypertrophy and remodeling. However, to be really efficient, certain conditions need to be considered. The amount, type and source of proteins do all matter, as well as the timing of ingestion and spreading over the whole day. Optimizing those conditions favor a positive net protein balance, which in the long term, may result in muscle mass accretion. Last but not least, it is also essential to take the nutritional status and the exercise training load into consideration when looking for maintenance or gain of skeletal muscle mass. In certain pathological states, the decrease beyond a minimal amount of skeletal muscle may be vital. It is therefore crucial to develop the most efficient strategies to enhance, in athletes, or to preserve, in patients, skeletal muscle mass. Up to now, combining protein intake and resistance exercise training has revealed the most efficient strategy, taking specific conditions into account, is to focus on the parameters that influence the efficacy of protein intake in regulating skeletal muscle mass. This contrasts with the overwhelming number of studies investigating the effects of nutrition, and more particularly protein intake, in conjunction with resistance exercise and not on muscle protein synthesis and breakdown. Not surprisingly, not all data have converged to consensual conclusions and clear-cut recommendations either for athletes or for patients. Proposes quite an exhaustive and up-to-date overview of the different parameters and conditions influencing the effects of protein intake on the regulation of skeletal muscle mass. However, further research is needed to determine how factors such as protein type, age, and the gut microbiota may influence those proportions. Certainly while animal sources, and particularly whey protein, display a more qualitative amino acid profile than vegetal sources in terms of protein synthesis stimulation, there is still some debate about the dose to be ingested after resistance exercise, ranging from 20 to 40 grams. Summarizing the data in this field, the authors came to the conclusion that 20 grams of high-quality protein, 0.3 grams/kg/meal, is sufficient to maximally stimulate muscle protein synthesis after a single meal and when repeated every 3 hours during the day. This dose may be increased when a whole-body resistance workout is performed, in somewhat heavier athletes with large muscle mass, and possibly in older individuals, though the latter point is still under debate. Another debatable point when looking at the effect of protein intake on muscle protein balance is whether protein should be jointly taken with a source of carbohydrate. The idea is that some amino acid transporters as well as the mammalian target of rapamycin, mTOR, pathway, a key regulatory pathway in the stimulation of protein synthesis, are insulin sensitive. Those results were confirmed by a meta-analysis, concluding that insulin is merely permissive for the stimulation of muscle protein synthesis. Based on this, it is not surprising that studies investigating the potential added value of combining carbohydrate and protein intake post-exercise have failed to observe a superior anabolic response compared to protein ingestion alone. Rather, insulin seems to positively regulate protein balance by inhibiting muscle protein breakdown. To end this video, for better results your intake should be 1.6 to 2.9 grains/kg/day. Follow for more science-based information.